This video is the fourth in a short series on antiderivatives and indefinite integrals, and this time we're looking at exponential functions. So we start out with the easiest case, and that's the natural exponential function e to the x. So we're trying to figure out the antiderivative of e to the x, the thing we differentiate to get e to the x, and then we have the plus c on this indefinite integral to make it the most general antiderivative. Next, we recall the extraordinarily simple behavior of the natural exponential function when we differentiate it. The derivative of e to the x is the same function, e to the x. It's the only non-trivial function that does this. So when we're trying to guess the antiderivative of e to the x, it's just the thing you differentiate to get e to the x, which is e to the x. So our indefinite integral of e to the x dx is just e to the x itself plus an arbitrary constant c to make it as general as possible. Now we extend to the trickier case, and that's where the base is not e, so we just wrote it as b. We're trying to guess the function you differentiate to get b to the x, and this begins by remembering the derivative behavior. So the derivative of b to the x is basically b to the x. That's the function piece of this. But there's also a factor of natural log b that's generated. So if we're trying to guess the antiderivative of b to the x, the thing you differentiate to get b to the x, the essential part of the answer is b to the x itself. But if I differentiate that, I get natural log b times b to the x, and I've missed by a factor of natural log b. All we have to do is supply that factor in the denominator. And now when I differentiate 1 over natural log b times b to the x, the derivative generates a factor of natural log b that then cancels out, and I end up with the correct function. So our indefinite integral of b to the x dx is 1 over natural log b times b to the x plus c. Again, you can always check these things by differentiating the right-hand side. As an antiderivative, when you take the derivative of it, it should give you the function in the integrand, and it all works out by canceling a factor of natural log b in this case. So let's wrap things up with a few short examples. In the first example, I'm asked for two possible functions f of x such that f prime of x is equal to 5e to the x. In other words, I'm looking for the antiderivative of 5e to the x. So one of these functions could just be 5e to the x itself. If you like, I've chosen an arbitrary constant of 0 there. Another unique function could be found by just choosing a different value for the plus c. And just to make things interesting, I'm going to throw in a pi. So 5e to the x plus pi, because when I differentiate that, I still get 5e to the x. In the next example, we have a non-standard base of 3. And we're going to have to adjust for a factor of natural log 3. So this is just directly quoting the formula that we found. I get 1 over natural log 3 times 3 to the x plus an arbitrary constant c. And again, just to reiterate that every antiderivative can be found by basically guessing and checking what the derivative is going to do to it. I can take the derivative of this expression, and when I apply that derivative to the additive constant plus c, of course I get 0 out of that. And the 1 over natural log 3 is a spectator when I differentiate the 3 to the x. And when I differentiate 3 to the x, I get natural log 3 times 3 to the x. Everything was set up to cancel out neatly, and I get the 3 to the x that I started with. Finally, we get a cumulative sort of example where I have an integral with a non-standard exponential in it, a natural exponential in it, and a 1 over x kind of term in it, which is going to integrate to a natural log. So in the first term, I end up with a 1 over natural log 2 times 2 to the x. In the second term, again, the constant multiples are just spectators here. The 3 just watches this happen, and the antiderivative of e to the x is just itself, so I end up with 3e to the x. And again, constant multiples are spectators, so I end up with a negative 5 times the integral of 1 over x, which gives me a natural log absolute value of x plus c. And we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.